Hello, so this lesson what we're going to do is recap everything that we've been doing to do with fractions. Okay, so what I suggest you do is each time we get to a question, if you know what you're doing, pause the video, do it, and then check that you've got it right. Okay, there are quite a lot of different aspects to this, as you will remember, and some of them you will have picked up better than others. Okay, now my job for you during this lesson is I want you to make a note of which bits of fractions you are totally okay with, which bits you feel like you just have got nowhere with, and which bits you can be helped with, and then you'll have got it. Okay, so you'll all be somewhere in between the yep, totally confident with this, and nope, feel like I've got to start from the beginning again. And then we can use that information later on when we're doing the tutorial. Okay, so like I say, have something to write with and keep a note of where you are with the different bits of fractions. Okay, so first of all, represent and identify shaded fractions. So pause the video and draw a diagram which represents 3/4. Okay, if we're representing 3/4, that means that our shape, whatever we draw, has to have been split into 4 equal pieces, and 3 of them should be shaded. Okay, so let's say we chose to do a circle. We could split it into 4 pieces like that. They're supposed to be equal, remember, and shade 3 of them. So that diagram represents 3/4. We could have drawn a rectangle or a square and split the quarters like that and shaded 3 of them. Or we could have drawn the same rectangle or square and split it like this and shaded 3 of those. Or, again, if we'd drawn a rectangle or square, we could have drawn corner to corner to split it into 4 equal pieces and choose 3 of them. So you might have a different shape to that, but as long as your shape is split into 4 equal pieces and 3 of them are coloured in, then your diagram does represent 3/4. Okay, next, finding a fraction of an amount. So pause the video, and if you know how to find 2/9 of 801, you go ahead and do that and come back and check your answer. If you're not at all sure, then stick with me just now. So remember, to find a fraction of an amount, you need to take the amount and divide it by the bottom number, by the denominator, because remember, the bottom number in a fraction is to do with sharing and dividing. So we need to split 801 into 9 equal pieces by dividing, and that will give us 1/9, and then we need to times that by 2 to get 2/9. Okay, so we're going to take 801, basically divide by 9 and then times by 2. So 801 divided by 9 using bus stop method. So 9 into 8 doesn't go, so we can carry 8. And then 9 into 80, need to think how many 9s are in 80. Go up your 9 times table. You'll get to 72, which is 8 9s. And again, that leaves 8 left over, doesn't it? And 9 into 81 goes 9 times. So 1/9 of £801 is £89. Okay? But we need 2/9, so we need to do 89, either times 2 or add 89. It doesn't matter which way we do that. Okay, so 9 2s are 18, 8 2s are 16, add the 1 is 17, so that gives us £178 as our answer. So just remember, you're dividing by the bottom and multiplying by the top. Right, next we're on to identifying and finding equivalent fractions. So our job here is to match the pairs and fill in the gap. So we will see there is a gap down here. Okay, so matching the pairs. So we're going to match each blue one to an orangey red one. Okay, to find equivalent fractions. Now remember, an equivalent fraction is one where the top and bottom have been either multiplied by the same amount or divided by the same amount, but the same thing has to have happened to the top and the bottom. Okay, so let's have a look. Let's just pick one. So let's look at 2/9. Okay, so looking at the other fractions, at the orange fractions, 2 has to have been multiplied by something to get the top, and 9 has to have been multiplied by the same amount to get the bottom. Okay, so there's no point in looking at this one because 2 doesn't go into 35. Okay, so we know it's not that one. 2 doesn't go into 15 either, so we know it's not this one. 2 does go into 24, so 2 times 12 is 24. But is 9 times 12 30? Well, it's not, is it? It's way more than 30. 9 times 12 is 108. So 2/9 doesn't match that one. It doesn't match that one. And it doesn't match that one. So we need to think about this. So 2 times 10 is 20. 9 times 10 is 90. So that does mean that these two fractions are equivalent. Okay? So let's try 3/4 next. Okay? So we want to find one of the orange ones where we can multiply the top, multiply 3 by a number to get the top, and multiply 4 by the same number to get the bottom. So let's have a look at 24/30 to start with, just because that's closest. So is 24 in the 3 times table? Yes, it is. And 3 times 8 is 24. 4 times 8 isn't 30 though, is it? 4 times 8 is 32. So we know it's not 24/30. So let's think about this one because that's the next closest. Is 3 times something 35? Well, 35 is not in the 3 times table. So we wouldn't be looking at this fraction as being equivalent to that one. So we need to look down here. So 3 times 5 is 15. So the bottom number would have to be 4 times 5, which would give us 20. So 15/20 and 3/4 are matching pairs, okay? Now we knew it had to be the 15 over something because it couldn't have been the other two. Remember, we checked those, okay? So looking at the next two, we've got 5/8 and 4/5. Looking at our top numbers, we've got 35 and 24. So 5 has to multiply by something either to get 35 or 24. And 4 has to multiply by something to either get 35 or 24. So if we're being sensible about this, we're going to look and see if these two are an equivalent pair. Okay, 5 times what is 35? Well, 5 times 7 is 35. So if 8 times 7 is 56, then we've got equivalent fractions there. And 8 times 7 is 56. So we know that these two fractions are equivalent. And then hopefully 4/5 is 24/30, same size. So we'll just double check that. 4 times what is 24? Well, if we go up our 4 times table, we can see that 4 times 6 is 24. And 5 times 6 is 30. So the top and bottom have both been multiplied by 6. So that means that these two fractions, happily, are also equivalent. Moving on, simplifying fractions. Now remember, we have done a lot. So if you know how to simplify these, pause the video, do it, and come back and check. Okay, so when we're simplifying fractions, we're dividing top and bottom by the same amount. So we need to find a times table where we'll find 42 and 56. Now, there are choices here, but I'm just going to go with 2 at the moment because sometimes you might not spot the biggest number that goes into the top and bottom. So I'm going to divide top and bottom by 2, okay? Right, what's 42 divided by 2? Remember, dividing by 2 is just halving. So half of 40 is 20, half of 2 is 1. Okay? Half of 56 then. Half of 50 is 25. Half of 6 is 3. So we've got 28 altogether. Okay, now look at 21 and 28. Is there a times table that 21 and 28 are both in? Well, they're both in the 7 times table, aren't they? So we can divide top and bottom by 7. So 21 divided by 7 is 3 7s in 21. And there are 4 7s in 28. So 28 divided by 7 is 4. So 42 over 56, when it's simplified, becomes 3/4. Okay, and then the next one, just clear a bit of space, 15 over 45. We've got a choice again of numbers that we could divide top and bottom by, but I think the most obvious one is 5. Okay, so we're going to divide top and bottom by 5 to start with. That's a nice easy one, isn't it? 15 divided by 5 is 3. 45 divided by 5 is 9. And then it's really clear to see we need to divide top and bottom by 3, don't we? Because 3 and 9 are both in the 3 times table. So 3 divided by 3 is 1. 9 divided by 3 is 3. So a third is what we get when we fully simplify 15 over 45. And just so you know, in the first one, the biggest number that you could have divided by to get straight to the answer was 14. They're both in the 14 times table. 3 14s and 4 14s. And in this one, they're actually both in the 15 times table. So 1 15 and 3 15s. So that's where the answers could come from if you went straight there. But remember, you can take several steps to get there, and it doesn't matter. Okay? Next, convert improper fractions to mixed numbers and vice versa. So we are going to start the other way around though. We're going to start with a mixed number and change it to an improper fraction. So remember our method for doing this. We need to think about a number of quarters. So again, pause the video if you know what you're doing. Just do it and then come back and check. So we need to find out how many quarters are in these 5 whole ones. So to do that, remember we do 4 times 5. That gives us 20. So we've got 20 quarters in these 5 whole ones. And we've got another 3 quarters. So we've got 23 quarters altogether. All right, and then the next one, 27 over 5, to change that into a mixed number. We need to know how many whole ones we can make if we've got 27 fifths. So we do 27 divided by 5 because remember in each whole one there are 5 fifths. So 27 divided by 5 is 5 with 2 left over. 5 remainder 2. So what this means is that 27 fifths is equal to 5 whole ones and 2 fifths. Okay, so when you divide, the answer goes here and the remainder goes there. All right, next, adding and subtracting fractions. First of all, with the same denominator. Remember what I'm wanting you to do in this lesson is keep a note as we go through of which topics within fractions you're good at and which ones you need more help with. Okay, so same denominator. So think about this just in a logical way. If you've got 4 ninths and 1 ninth, you have got 5 ninths altogether, haven't you? Okay, they don't all of a sudden magically change into 18ths. So 4 ninths add 1 ninth gives us 5 ninths. Okay, and then we're doing mixed numbers here. So we've got 1 and 2 sevenths add 2 and 3/7. So basically what we've got here is we've got 1 and 2/7 and 2 and 3/7. So we can say that 1 add 2 is 3, and then 2/7 add 3/7 is 5/7. So altogether we've got 3 and 5/7. Now, when we're adding and subtracting fractions with different denominators, we need to find a common denominator. So remember, in order to do that, we need to find a number that is in the 4 times table and it's in the 6 times table as well. So if you go up your 4 and your 6 times tables, then the first number you reach that's in both times tables is 12. So we're going to change these fractions to 12ths. So 3/4 is going to become a number of 12ths. And the way that we do that is we create equivalent fractions like we just looked at. So we see, what has the 4 been multiplied by to give us 12? Well, 4 times 3 is 12. So we need to do 3 times 3 to get the top number here. And then, looking at the second fraction, what have we multiplied 6 by to get 12? 6 times 2 is 12, so we need to do 1 times 2, because you've got to do the same to the top and bottom to get 2 there. So now we can work out the answer, because we've got 9/12, take away 2/12, gives us 7/12 in the end. Okay, and then the next one, 3/7 add 5/14. Again, we need to find a common denominator. So we need the smallest number that we can think of that's in the 7 times table and it's in the 14 times table. And we don't have to go very far up those timetables, do we, to find that the number that you come to first that's in both lists is 14. So then we just look and see what we've done to the denominators and we do the same to the numerators. So 7 times what is 14? Well, 7 times 2 is 14, isn't it? So we need to multiply the 3 by 2 on the top to get 6. And then in the second fraction, we haven't done anything to the 14, so we don't do anything to the 5 either. So we've got 6/14, add 5/14, so therefore we have got 11/14 altogether. Right, okay, we're getting through this, aren't we? So now multiplying fractions. Remember that phrase that we came across? Simplify before you multiply. Okay, so when we're multiplying fractions, we can simplify anything on the top with anything on the bottom. All right, so we can spot, for example, in this first one, that 4 and 8 are both in the 4 times table. So we've got 1 4 there and 2 4s there. So 3 and 5 are not in the shared times table, so we can do our multiplying now. So on the top, we've got 3 times 1 is 3, and on the bottom, we've got 2 times 5 is 10. All right, that's it, 3/10. Won't simplify any further because we did our simplifying before we multiplied. And the next one. Okay, looking at times tables on the top and the bottom, we can see we've got the 5 times table in these two numbers. So we're going to divide the 5 and the 20 by 5. So 5 divided by 5 is 1, and 20 divided by 5 is 4. Now looking at the other numbers that we've got left here, we've got 9 and 6, and they're both in the 3 times table. So dividing the top and bottom by 3, we get 3 3s are 9, 2 3s are 6. So altogether we've got 1 times 3 is 3 on the top, 2 times 4 is 8 on the bottom. So our answer is 3/8. Okay, so on to dividing fractions next, which is very much like multiplying, because it involves multiplying, doesn't it, if you remember? So remember our method for dividing fractions was you leave the first number as it is, or the first fraction, and then we've got to do some multiplying, but we multiply by the second fraction when it's been turned upside down. So the 4's on the top now, and the 1's on the bottom. So then we do what we were just doing a moment ago with our multiplying. We do our simplifying first. So we can see 4 and 8 are both in the 4 times table. And we've got 1 4 in 4, and 2 4s are 8. A quick look shows us we don't have any more simplifying to do here. So 7 times 1 is 7, and 2 times 1 is 2. So we've got 7 over 2, which is okay to leave like that, or if we wanted to, because it's an improper fraction, we could turn it into a mixed number. So remember how to do that. We would do 7 divided by 2 is 3, remainder 1. So we would have 3 whole ones and 1/2. Alright, and then the next one, we leave the first fraction the same, then we times by the upside down version of the second one. And we see if we've got any simplifying to do, and we have, because we've got 5 and 10 that are both in the 5 times table, so that's 1 5 and 2 5s. And then 3 and 9 are both in the 3 times table, so we've got 1 3 and 3 3s, so that when we multiply, we've got 1 times 1 is 1, 3 times 2 is 6. So our answer there is 1/6. Okay, remember, make a note of anything that you're going to need help with. Alright, then add, subtract, multiply and divide mixed numbers. So we've looked at this a little bit already, but we're going to have to do something a bit fancier with the second one here. So the way that I'm suggesting you do this is deal with the whole numbers first. Okay, so what we've got here, remember I broke that last one down. So 3 1/3 means 3 add 1/3. Add 4 and add 3/4, because everything's adding up. So what we can say we've got there is we've got 3 add 4, so that gives us 7. And then we've got 1/3 and 3/4. So if we do our process for adding fractions just on this bit, then we'll get to the answer. Okay, so keeping the 7. So if we look at thirds and quarters, we can see that the common denominator there is going to be 12. So if we're changing the 3 into a 12, then that means we've multiplied by 4. So you've got to do the same to the top as well. So that's going to make that 1 times 4 is 4. And then the second fraction, we've done 4 times 3, haven't we, to get 12. So we need to do the 3 times 3 to get the answer here, which is 9. Okay, so we've got now 7. And then we've got 4 12ths and 9 12ths. That makes 13 12ths. Is that okay for an answer? Well, no, that's a bit odd, isn't it? Because that's a mixed number and it's got an improper fraction in it, which is not good form. We don't stick with that. So we need to change this, okay? Remember 13 over 12, 13 12ths. If you've got 12 12ths, you've got a whole one, haven't you? So we've actually got another whole one, so we've got 8. And then you've got an extra 1 12th there. So 7 and 13 12ths is exactly the same amount as 8 and 1 12th. Okay? Now, we're going to do something similar, but we've got to be super, super careful with this. If we've got 5 and 2 fifths, we know that means 5 add 2 fifths. Okay? And if we're taking away 2 and 1/6, it means we're taking away 2 and we're taking away 1/6. Okay? So that makes sense, doesn't it? We've got 5 and 2 fifths, and we need to take away 2 and take away 1/6 as well. So what we've got here is, in our whole numbers, we've got 5 take away 2 is 3. And then in our fractions, we've got 2 fifths take away 1/6. So we need to now get a common denominator and work out what this is. Okay, so it means we're going to stick with having 3. And then our common denominator is going to be 30 for the 5 and the 6. All right, so 30 is the smallest number that's in the 5 times table and in the 6 times table, isn't it? So 5 has been multiplied by 6 to get 30. So 2 times 6 is 12 on the top. Then 6 times 5 is 30, and 1 times 5 is 5. So what we've got here is 3 whole ones, and then we've got 12 30ths minus 5 30ths. So 12 take away 5, we've got 7 30ths. Okay, so that's one way of adding and subtracting mixed numbers. There are other ways, but I think that's probably the best way for us to stick to just now. Then we've got some more here, got another one. The reason why I've put this next one in, why we've got 2 subtractions, is to show you what it's like when we have the equivalent of this situation here, where we ended up having to go into the next whole number. So we've got an equivalent of that happening here, as we'll see in a minute. Okay, oops. So what we've got 7 1/4, and then we're taking away 4, and we've got to take away 5 6 as well, because if we're taking away 4 and 5 6, we've got to take away the 4 and we've got to take away the 5 6. So in our whole numbers, we've got 7 take away 4 is 3, and then we've got 1/4, and we need to take away 5 6. So what we're looking at is 3, and we need a common denominator for the quarters and the 6. So the smallest number we need to find now is the smallest number that's in the 4 times table, and it's in the 6 times table as well. So the smallest number in the 4 and the 6 times tables is 12. Okay, so we just look at what we've been multiplying by and create our equivalent fractions. So 4 times 3 is 12, so we need to do 1 times 3 on the top there. Then 6 times 2 is 12, 5 times 2 on the top is 10. So we've got 3, and then we're adding 3 12ths, but taking away 10 12ths. So if you're adding 3 of something and taking 10 away, effectively what you're doing is taking away 7 of them, isn't it? So it's 3 take away 7 12ths. Now remember, there are 12 12ths in a whole one. So if we start off with 3 whole ones and take away 7 12ths, then we're taking away part of this one, aren't we? So we've still got 2 left, but this whole one that's had 7 12ths taken out of it, what's left must be 5 12ths, because there's 12 12ths altogether. Okay? That's why I wanted to do that one, was to show you about going backwards into the next number. Okay, now we're on to multiplying and dividing. For multiplying and dividing, you've got to change your mixed numbers into improper fractions before you start. So, remember how we do that? It's times and add, times and add. So 5 times 3 is 15, add 4 is 19. And we're multiplying that by 1 and 9/10. So 10 times 1 is 10, add 1 is 19. Sorry, add 9 is 19. So remember, that's tenths. Now, the reason I've put this one in is because, remember our phrase simplify before you multiply. It might look to start with like this can be simplified because we've got a 5 and a 10 there and 19 and 19. But I'm afraid that you can't simplify because you've got to have something on the top and the bottom when you're simplifying, haven't you? So what we need to do, there's no simplifying to be done there. It's just 19 times 19 on the top, which if you work that out, you can either do it as a long multiplication or you could be a bit sneaky and use a calculator. But either way, you're going to get 361. And 5 times 10 is 50. Now, if we wanted to, we could change this into a mixed number. So how many 50s are in 361? Well, if we go up our 50 times table, you've got 50, 100, 150, 200, and so on. So what you'll find is that you've got 7 50s in 361, and you've got 11 left over. So these last couple of questions that we've done here, they are at the top end of what I'd be expecting you to be able to try in fractions, okay? So if you're managing these questions, then that's absolutely brilliant. If you're finding this difficult, it's understandable. That's okay. I still want you to try, but it's okay to need that explaining and need a bit of support with understanding this. Okay? And then we've got 4 3/8 divided by 1 1/4. So we have to do the same again and change these into improper fractions. So we're going to do 8 times 4 is 32. Add the 3 makes 35. So we've got 35 over 8. And then we're dividing by 4 times 1 is 4, add 1 is 5. So we're doing 35 over 8 divided by 5/4. And remember that when you're dividing by a fraction, you have to multiply it by the upside down version of the second fraction. Okay, so we'll have a look now and see what simplifying might be possible, because we have got numbers on the top and bottom that can simplify now. So looking at the 4 and the 8, 4 times table, we've got 1 and 2. And then looking at the 5 and 35, we've got the 5 times table, 1 and 7. So when we multiply, we've got 7 times 1 is 7, 2 times 1 is 2, and if we wanted to write that as a mixed number, then we can do 7 divided by 2 is 3, with 1 left over. So it's the same as 3 1/2. Right, so that's taken us quite a while to get through all that. Remember, I wanted you to make a note of what you're fine with and what you need help with, and then that can be discussed with your teacher in your tutorial on this. So I need to say a huge well done to you guys. That's been a big topic, and your fractions work is now in the bag. We've got one more lesson to do on fractions, another video lesson, and that's going to be using fractions in wordy questions or in context. And I would just like to say, please remember, my Improper Fractions helpline is open 24/7, but only a fraction of people will find that funny. I'm going to leave you on that note and say well done, and I'll see you soon.